all the different characteristics comets could have, and just remarkable instances like fragmenting comets, like comets with large tails, brilliant comets, that sort of thing. And I drew some inspiration, and I thought a couple of different characteristics I find interesting about comets, and try to think of the comets I felt best met those categories. And so that's what I'll do tonight. So I'll just start with a little bit of introduction first. So basically, this is me in 1977, believe it or not. So I've been observing 43. I've been observing for 43 years, and so at the time I had an 8-inch Newtonian, which I actually purchased by selling a motorbike. And you know, my parents were good enough to help me repair the motorbike, and we got it for sale. And we found this 8-inch Newtonian reflector in our local classifieds for sale, classifieds. And so I purchased this, and here I am. I think we're observing one of the planets down low in the east. And so I started my hobby. And then as time went on, I got a bit more serious about the hobby, and I started a comet survey in 2006, and that ran until 2017. And I found 6 comets in that time. So currently on a bit of a hiatus from comet hunting. I've actually picked up more with observing and astrophotography a bit more. So I'm being a bit more passive about my astronomy than I have been. There's a lot of time involved in searching for comets, and I have felt a need to just to step back a little bit and actually enjoy the hobby a bit more. So back to the topic of remarkable, or my top 10 comets. First category, I thought of Earth-grazing comets. Now, comets that approach the Earth to within 0.1 astronomical units are often called Earth-grazing comets. Now, because brightness increases with a square law with respect to distance, a comet that's 0.1 astronomical unit from the Earth will appear 100 times or 5 magnitudes brighter than when it is at 1 astronomical unit from the Earth. So consequently, even a small comet can become large and bright. And I've seen a few of these comets, but the one that's the most outstanding was a comet that appeared way back in 1983 called Comet Iris-Araki-Alcock. This is just an announcement at the time for the comet, but of particular interest to a lot of you people out there is it was the last comet discovery by the famous George Alcock. Apparently George found the comet viewing through a window, so it was actually discovered inside a house looking out for the window. One of the few instances I could find, you know, in the annals of astronomy that of a comet being discovered from within inside a house. Because it was pre-internet back in those days, news of it actually spread fairly slowly, or what would happen is you get bits of news would arrive. So at the time, being in the Southern Hemisphere, we had very little information, and the comet wasn't visible for us. So we really didn't know how bright it was. So we knew that it would appear first here for us on May 11th, which was when it was close to the Earth. If you actually have a look at the orbit, you can see here the comet pole vaulted over the sun and literally almost hit a bullseye on the Earth. So its closest approach was on May 11th, and it would be only 0.03 of an astronomical unit from the Earth. Not only that, because of the way the orbit was inclined at a very steep angle, the relative speed between the Earth and the comet was very high. So the motion across the sky was 43 degrees per day, which is about 2 degrees an hour. So remarkable in the highest apparent motion I can ever recall of a comet. So fast, in fact, you could see the comet moving in real time. So I don't have any photographs of the comet, but I do have some sketches I made. So as I said previously, the comet appeared very suddenly for us on the May the 11th. And but for us, it was better the following night when it was higher up in the sky. So here I have a sketch, and you can see the comet had quite a well-defined nucleus, and a very interesting fan shape structure. And I think one of the most interesting things was actually watching the comet with a star field in the background and watching the comet drift a bit like a distant satellite across the field of view. So I wrote on that morning, that evening, the comet appeared much brighter than M44, which is the famous star cluster in Cancer. Conditions hazy with cloud. At 7:45 p.m. it appears as an enormous blob to the naked eye, similar in brightness to Denebola in Leo. Strongly visible to the naked eye. And I also noted 140 times its magnification. The central condensation could be seen moving in real time against the starry background. Because I don't have any photos of the comet, I stole a page out of Sky and Telescope. So you can see here M44 up here, and you can see the comet to give you an idea of what it looked like. So that was my Earth grazing top 10, if you like, comet. So the next category was famous periodic comet, and there's only one comet that this could be, and that's Halley. Much maligned comet. Many people regard it as a flop and disappointment, but this is more to do with expectations. When people say it was a flop, I often point them to this chart here, which showed that the comet these were predictions that were made a few years before the comet appeared by JPL NASA, by Don Yeomans, and it showed the comet reaching a peak of no brighter than 4th magnitude. In fact, at the time, Sky and Telescope mentioned that it would be no better, if not less impressive, than Comet Kohoutek in 1973. 1974. Now, Comet Kohoutek, if you don't know, was often put up as an example of comets that underperform. And so here we are saying it's not going to be very impressive. In fact, 4th magnitude is not going to be, you're not going to see much with the naked eye. So that was actually the reality of what was predicted. However, the media and various people got hold of Comet and probably presented it more, hyped it up more than it needed to be hyped up. So anyway, the comet, I've started seeing the comet in 1985, so probably about 6 months before its closest approach. But one of the more memorable moments was actually seeing Halley in the same field of view with the Crab Nebula up here. So this is the view through my 8-inch telescope at 50 times. One thing I noticed in comparison with the Crab Nebula was that the fact that the comet had a very small, bright core whereas the Crab Nebula was a much more uniformly, much more uniform in brightness. Later in the year, I got some fantastic views of Halley's Comet from a place called Mount Caputar, which is in north central New South Wales. It's almost 5,000 feet above sea level there, and the transparency, sky transparency, and sky quality is first rate. So these were drawings I made with 15 by 80 binoculars. So at the time you could see the tail in binoculars and you could see the comet with the naked eye. Just a couple of sketches here. So one thing that was interesting, and just to show you, this isn't an issue that exists just today, but at the time people were overhyping the comet, and a number of magazines, a number of people were predicting that because the comet was brightening rapidly through October, November, and into early December, that brightness rate would continue increasing all the way to perihelion, and there were predictions of third, second magnitude, even magnitude -1. However, what happened was a little bit different. So instead of being magnitude 3 or 2, it was actually ended up plateauing at around magnitude 4 and 5. So it was a slightly disappointing comet in January 1986 before it disappeared into the evening twilight. And here's a couple of sketches. The top sketch there shows what it looked like in binoculars. Luckily, after it disappeared into twilight, it would reappear in the morning sky in February. But luckily, in that time it had disappeared, it had developed very nicely. So now it was a really nice comet, at least in binoculars. So you can see here's a picture here. And by the way, my apologies, these were just copied straight out of my sketchbook. So I used to do a lot of comet sketching at the time. But here you can see the comet low down in the east, in the morning sky. Here's the trees, silhouette of the trees. There's some cloud here. And the comet appears just below the cloud deck. And you can see the tail going up into the cloud and even shining through the cloud a little. So actually it was a very, very nice comet, you know, at the time. Probably the best views I had were in March. And here is a sketch showing you what it looked like in 15 by 80 binoculars. So you could actually see there was a bit of it on March the 21st. There was actually a bit of the tail had disconnected and moved away. Generally, I found the comet quite easy to see with the naked eye, including the tail. So it's actually not a bad comet and probably better than expected. You know, if you consider the original expectation of it only reaching magnitude 4 and it actually reached magnitude 2, it didn't do too badly. In April, I saw the comet from above the Pacific Ocean, and I made this sketch here from the window seat. The plane, at the time we were flying, I was actually hosting flights, comet viewing flights. So I actually got to see the comet for 6 consecutive nights from 35,000 feet in April. This is a sketch I made from the window view with all the lights turned out in the cabin. However, I think some of the disappointment with the comet came from the fact that many pundits had actually predicted the comet would be best in April, around April 11 or April 12th. In actual fact, the comet had other ideas because what people had not anticipated is the distortion the tail would have in the perspective and the way that we were viewing it from Earth. So the Earth comet geometry was such that we were basically looking down the tail. So the tail looked very, very distorted like this. So when you looked at it with the naked eye, it just looked like a smudge, basically. So it didn't look like a comet, and left a lot of people disappointed. What I found at the time is a lot of people had come from flown from the northern hemisphere down to Australia or down to South America or South Africa to see the comet at its predicted peak, and then they started leaving around the middle of April. But what people hadn't predicted is that the tail would then close up and actually get better during April, as you can see here. So it started looking like a comet again, and we got a fantastic view around April 24th when there was a total eclipse in the eastern part of Australia. And I remember as the moon went into total eclipse, the comet started to appear with the naked eye with up to 40 degrees of tail. If the comet had been another magnitude brighter, it would have been a great comet that night. I do have photos, but unfortunately, somebody borrowed them and never returned them, so I can't show you those. So now we leave Halley. Now, the next category of comet that I felt was a standout for me and making my top 10 is the comet called Comet Shoemaker-Levy. At the time, it's called Comet Shoemaker-Levy 9, but now the correct designation is D 1993 F2. So this comet was famous for its collisions with Jupiter. As you can see here, this Hubble photo showing one of the impact zones. I never actually got to see the comet itself. It was around 13th or 14th magnitude, and a bit too faint for me visually, but it certainly saw the aftermath of the comet. So if we go to the next slide, this was a confirmation of Discovery comet. This is the confirmation observation showing you the comet at the time. And I believe Mount Palomar, observers at Mount Palomar had actually sighted the comet a few days earlier, but didn't believe it was real because no comet looks like this. So it's a very unusual comet indeed. So after a couple of months, it was realized that the comet could actually collide with Jupiter, and it was that point that people started to get really excited about the comet because it took a while for the orbit to be properly locked down, but when we did, we realized that it's an exciting prospect that this comet, we would actually watch this comet crash into the planet. Meantime, Hubble was able to photograph the comet and reveal at least 20 fragments. This image taken on July 1st, 1993 was actually before the corrective optics for the Hubble were put in, but even so, it shows the string of pearl effect of the comet. So further observations revealed July 16th to the 22nd was the date when the fragments would collide. And I think what added to the excitement at the time was what would happen when the people anticipating what would happen when the comet hit Jupiter. And, that ranged from us seeing bright flashes on Jupiter to Jupiter just swallowing up. So I think a lot of the excitement was also anticipating what would actually happen. And boy, did something happen when the comet started hitting this. So on July 16, the first fragment hit behind the limb of Jupiter out of view, but a couple of telescopes saw a plume coming up behind the planet's limb, and minutes later, the actual impact area rotated into view, and here's the black eye effect that we got. What was amazing about this event, if I flick to the Hubble shots here, was that anyone with a small, moderate-sized telescope could go out into the backyard and watch these things and see these things. They basically look like black eyes on Jupiter's surface. They really were remarkable, and they remained there for, I think, a couple of months. I think about 3 months, all told, before they finally dissipated. Here, this July 22nd image here shows you a time sequence showing you the impact as seen, or impacted fragment W from the Galileo spacecraft, which was en route to Jupiter at the time. So it's one of the few direct views we have of the impact. So that was a remarkable comet. Now getting onto my next top 10 comet. This one, Comet Yakutaki, which appeared in 1996, is remarkable because it had the longest tail I've ever seen in a comet. But I'll discuss that very shortly. But I just love this beautiful photograph of this comet here from using an ultra wide angle lens from Japan. Really gives you the impression, if you look in the center, you'll probably make out the Ursa Major to give you some scale. So Comet Yakutaki, he actually found 2 comets in quick succession. The first one was not particularly interesting, didn't really brighten. However, the second comet discovery on January 30, 1996 was different. Within a few days of its discovery, we realized that not only was the comet actually going to approach relatively closely to the sun and therefore brighten considerably, but it also approached the Earth to almost 0.1 of an astronomical unit, therefore being effectively an Earth grazing comet. This would happen on March 26, 1996. Predictions at the time were estimating that the comet would reach magnitude 0. But on the flip side, people were expecting, well, a number of comet experts were predicting that the comet would, even though it would be magnitude 0, it would be very large and diffuse, and any tail would be quite faint. But obviously our eyes were eagerly watching the sky, looking at this comet. And this picture here was one of my first photos on February the 11th, showing the comet about 7th or 8th magnitude at the time. Here's a sketch I made using a very old version of Microsoft Paint, I guess, but shows you the views for a 10-inch telescope late in February 1996. At the time, it was still not visible with the naked eye, but after this point, the brightness increases were happening every day. So each day the comet was getting brighter and brighter. And then from 3 weeks from this 7th magnitude object, not visible on naked eye, it had developed into a spectacular naked eye comet. So I wrote on March 21st, 1996, magnitude 1, good sky conditions, spectacular naked eye comet with 15 to 20 degrees of tail clearly visible with a naked eye. And this image here, this drawing here was actually made at the time, showing you the what it looked like in binoculars. And in binoculars, I actually tried to trace out all the knots and filaments that I could in the tail. It truly was amazing. So in 10 by 50 binoculars, I could see filaments and knots and twirls and all sorts of detail in the comet's tail. It really was quite remarkable. Best views, however, came for us anyway in the Southern Hemisphere, probably around March 24, 25th, 1996. This is the photo of the comet. Hadn't yet risen, but the tail could be seen rising up from the northern horizon for a couple of hours. And here's a photo here showing, I think it was around 11 o'clock at night, showing the tail just poking up from behind the horizon. By the early morning, the comet had fully risen, and this was a photo I'd taken just with a normal camera lens, so nothing special. I think at the time I measured the tail to be 52 degrees. So basically, with the comet fairly low over the northern horizon, the tail went straight up into the sky and almost overhead. So 2 nights later, even though the comet's head was near Polaris, so down here in the southern hemisphere, you couldn't see the head of the comet. However, the tail could still be seen pointing up from the northern horizon. In fact, I got an observation with the tail stretching from the horizon to 40 degrees above the horizon, which gave a total of about 60 degrees of tail. In fact, when you see some of the drawings, the old drawings of comets, the woodcut drawings, this really reminded me of a woodcut drawing just stuck up in the sky. It really was amazing. For the southern hemisphere, the comet returned into the morning sky in May, but it was just a shadow of its former self. And here is a photo I took then. Even though it was a shadow of its former self, it was still quite a respectable comet. It was still quite impressive in binoculars. So about the same time that Comet Hyakutake appeared, there was another comet being watched, Comet Hale-Bopp. This one I call the giant, put it in the giant category. And to basically explain what that is, we have a yardstick measurement for comets called absolute magnitude, which is the brightness a comet appears if it was exactly 1 astronomical unit from the sun and from the Earth. So most comets come in at around magnitude 7 through to magnitude 11. They're the ones that we would see for, as amateurs in visually in telescopes. So generally, most comets, if placed 1 astronomical unit from the Earth and 1 astronomical unit from the sun, would appear between 7th and 11th magnitude. Now, a really nice bright comet would come in at around about magnitude 6. Even brighter, great comets typically come in around about magnitude 3 to 6. So a comet with an absolute magnitude of 3 would be considered quite a rare comet, particularly one that came into the inner solar system. Maybe twice a century, we'll get a comet with an absolute magnitude of 1 appear in the inner solar system. these examples of comets are very rare. To give you an idea, yeah, twice a century. So in 1744 we had one, 1811 we had one, 1825, 1882, and 1914. So when Comet Hale-Bopp appeared, though, astronomers could not believe how bright this comet, and they thought it had actually flared and was enormously bright when it was found. But it clocked in with an absolute magnitude of -1, which is absolutely unprecedented in the records of comets. So it's essentially intrinsically the brightest comet that we've ever seen in a solar system, as long as records have been kept. So it definitely gets my approval as in the top 10 as a giant comet.
And take a look at the weather. Here is.
So just some observations I have of the comet here. This is just with an experimental CCD camera I designed and built at the time, showing you the development of the comet through 1996. It was quite amazing in a telescope. Actually, there was a lot of detail visible, jetting and structure in the nucleus. It's quite a unique comet. I traveled to the US to see the comet, and this was my first view after probably a 5 or 6 month hiatus. I'm not seeing the comet being stuck in the southern hemisphere. It really was a northern hemisphere event, this one, and not long after I got off the plane, after about 14 hours, we drove to the top of a mountain north of LA. I was confronted with an absolutely beautiful view of the comet. I think the first thing that struck me about this was just how bright the head of the comet was. So it was at least magnitude 0. So it really looked like a brilliant fuzzy star with a naked eye.
John here, I've lost the picture.
Sorry?
Has anybody else lost the picture? I've lost Zoom.
I've lost the picture too.
All seems to be okay for me.
Yeah, it's okay for me.
Okay.
Would you like me to keep going?
Yeah, there's no problem.
I'll relog on again.
Okay.
Okay. Would you like me to pause for a moment?
Yeah, if you pause for a moment, I'll let him back in then, Terry, if that's
Thank
okay.
you.
Okay. Well, I'll leave this picture of the comet up on the screen. While waiting for those people to come in, can everyone see down here the Andromeda Nebula, M31, or the Andromeda Galaxy, I should say? I've just got the highlighter on it down there, just for comparison.
Okay, I'm back in. John's back in. John McAvoy, thanks.
Okay, I will continue on. So my first impression of how Bob was just how bright the comet was. Now, admittedly, though, even though the initial part of the tail was very bright, it faded. The tail brightness didn't maintain for very far. So the comet was probably a bit smaller than I actually expected. It didn't look like a particularly large comet with a naked eye. Some people will probably laugh about that, but I think some people expressed a bit of disappointment about that. But I still found it was still a spectacular comet. But probably, I think one of the aspects that blew me away with Comet Hale-Bopp was the structure around the nucleus. So I had a look online. I tried to find some images, I think, that really portrayed this shell structure and jetting structure that you see in the nucleus. but I couldn't really find it. This is about the closest I could find. But in, say, like a 10-inch telescope, you could see the shell structure, usually in only one night, 3 to 4 shells around the comet's nucleus, and they were very easy to see in a telescope, and very distinct. And not shown here also was the color. There was a mixture of yellows and turquoise sort of colors mixed in with jetting, which is obviously mixtures of gas and dust. To me, that was one of the more remarkable aspects. But in April, so this all happened around March, April 1997. So in April, early April 97, I think, was probably the best viewing of this comet. And this is one of my favorite images taken from Idaho. At a place called Galena Pass, which is about 8,000 feet, 2,500 meters up in the mountains in Idaho. And I have to say, I nearly froze to death that night, but geez, it was worth it. Best description I've heard of this comet was by a fellow comet discoverer, Rodney Austin, who called it a real hammer blow of a comet. So back in warm Brisbane again, this was the following month. The comet wasn't particularly well seen from the southern hemisphere, but I did get some memorable views of the comet. This one I'll always cherish, which was the crescent moon and the comet. Because the comet was still first magnitude at the time, the moon really didn't diminish the visibility of the comet. So they both looked almost as distinct as one another in the sky. A couple of months later, I got this photograph in the far southern sky. Comet was still visible with the naked eye. In fact, at this point, it had been visible with the naked eye for well over a year. And it almost seemed like a permanent fixture. And even today, I believe if anyone who made a decent effort at it could actually image the comet now. I think the predicted magnitude is 25. The last recorded observation was in 2013 at magnitude 24. Given that we can regularly get down to close to magnitude 30, I think the comet should be followed for some time. And for academic interest, the comet does return in the year 4385 AD. So my next category, if you like, is comets that appear by surprise. These are comets that kind of sneak up and go undiscovered until they're at their brightest and then make a sudden appearance. It's less likely these days for a comet to do this, but certainly decades ago, we would have comets that would just usually approach from the opposite side of the sun from the Earth, would brighten, become reach their peak brightness, and then suddenly reappear into the sky. And these comets would be discovered by airline pilots and casual astronomers. I think there was one discovered in Queensland by a school headmaster in the late 1960s. So the one that I think stands out for me that there was a surprise comet was Comet SOHO 1998 J1. So the comet appeared in the SOHO spacecraft in the solar coronagraph camera very suddenly in the end of April 1998 at magnitude 0. So it was already a brilliant comet. And within a few days, we scrabbled to get an orbit for the comet, and at the time the positions was difficult for us to calculate an orbit from the images from the SOHO spacecraft because it was in a different location in space to the Earth, so we didn't have an easy way of accurately calculating the comet's trajectory. So it meant that the comet, even though it was anticipated, we didn't know exactly where it was in the sky, so the predictions were a little bit out. But within a few days, it reappeared in the evening sky, and boy, what a beautiful comet it was. And this photo was taken, I believe, on May 18th, 1998. And you can see part of Orion up the top here. You can see Rigel, and you can see the belt of Orion here, just for scale. So 2 nights later, driving out to a dark sky, I got this photo of the comet. At the time, I remember putting 10 by 50 binoculars on the comet, and I could trace the tail for nearly 2 fields of view. It really was very beautiful. And the following night, here's another photo I took. So here you can clearly see Orion, probably upside down to what you guys are used to. So Rigel on the left and Betelgeuse on the right. And up here you can see the Rosetta Nebula. And if you look carefully, you can see the tail poking straight through Orion and up through the frame. So the length of the tail was basically almost as long as the length of Orion. So the next type of comet I thought that stands out for me is the comet that outbursts suddenly. And I had a couple of contenders for this, but the one that really sticks out in my mind is a comet called 2000 WM1 Linear. Essentially, 2 nights before this photo, or 2 mornings before this photo was taken, the comet was about magnitude 6. And an image taken with this same setup would have just shown a globular object down where the head is, and with a faint tail, thin tail pointing up. Within 48 hours, it went from magnitude 6 to nearly magnitude 2. But not only that, it went from a globular object with a faint tail to a spectacular comet with a hugely detailed tail. Through a telescope, it was very impressive as well. There was lots of jetting structure, lots of detail inside the head. It was really quite breathtaking in a 6-inch telescope that I had at the time. So that was my main pick. Now, if I was in the Northern Hemisphere, I almost certainly would pick the next comet. So there was actually a contender, and this was Comet Holmes. This is a photo of Comet Holmes, just taken with a short exposure photograph taken over the North Horizon. It wasn't very well observed from here, but essentially Comet Holmes went from magnitude 16 to magnitude 2.5 in under 3 days, which is probably the most energetic comet outburst ever recorded. Really a very remarkable object. I don't know if anyone's calculated the increase in brightness, but to go from magnitude 16 to magnitude 6 is a 10,000 increase in brightness. So magnitude 6 to 2.5 is about another 10. So we're talking about 100,000 fold increase in brightness in 3 days. Another comet that sort of stuck out as an outbursting comet was Comet Linear 2001A2, which is a great example of just how unpredictable comets can be. So this guy was only predicted to be magnitude 9, but ended up being magnitude 3, courtesy of a series of outbursts. Somewhat related, but probably worthy of their own category, is fragmenting comets. This photograph was taken, I believe, in June 2016. There's Comet Schwarzmann-Wachmann 73P. This is a fascinating, in binoculars, a fascinating double comet. This comet started breaking up in 1995, and actually, when I saw the comet back then, it had actually flared from about magnitude 13, which was invisible in my 10-inch telescope at the time. It actually flared from being invisible in a 10-inch telescope at magnitude 13, magnitude 14 or thereabouts, up to magnitude 5, which made it visible to the naked eye. However, it wasn't until its subsequent return in 2016, or one of its subsequent returns, that we got this perspective of the comet where fragmentation that had happened back in 1995 had meant that the components had moved apart far enough that you could see them like this. Although you could see two main comets, there are actually clusters of other fainter components. In fact, when Hubble imaged one of the fragments, this is fragment G, you can just see how many objects there are. Literally dozens of these fragments. So I think I remember reading there are orbits tracked for something like 70 to 80 different fragments. So quite a remarkable object, and maybe the current Comet Atlas might do something similar. We'll wait and see. The next standout comet from me, I think fits under the daylight comet category. This is a daylight comet is a very rare event, particularly a comet that's so bright that you can observe it in the middle of the day, even with the naked eye. And Comet McNaught in 2007 actually did that. In fact, on one day it was actually brighter than Venus, and you could actually see it if you had sufficiently clear skies. You could actually see it with a naked eye just by blocking out the sun with a hand. It had been the brightest comet since Comet of Kawasaki in 1965, and hasn't been equaled yet. And hopefully we might see something as bright, or if not brighter, in the future if we're lucky. So Comet McNaught, or its full designation, C2006 P1 McNaught, initially didn't create that much excitement. The brightening rate was very fast. It's a familiar story with comets. You know, on the way in, when they're still far from the sun, they can appear to brighten a lot faster. So people don't get too excited. And so observations through October through November in late 2006 suggested, you know, the comet was brightening fast, but that brightening rate would slow down as it got closer to perihelion. And in retrospect, we probably should have taken a bit more notice, because the observations in November suggested that the comet was actually quite a bright comet. But anyway, it didn't get too much attention until, here's a photograph, and you can see why I wasn't particularly excited with the comet. This is with a 300mm lens, admittedly low down in the sky, but the comet hardly showed up. So I wasn't particularly excited by this comet myself, but then towards Christmas time, people were starting to see it deep in the twilight, brighter than expected, around 3rd or 4th magnitude. And then early into January, people were starting to see it at magnitude 2 and then magnitude 1. At that point, we realized actually we might have a really nice comet on our hands. And at the time, I was probably a bit frustrated in the Southern Hemisphere because we couldn't see any of this. And we were reading the reports. However, when I started seeing reports of negative magnitudes, I decided to have a shot at it in daylight, and I was successful. So these were photos taken January 7th, 2007 through January 12th, showing the comet at midday, photographed through a telescope. But I think the probably one of my highlight views of this comet is when I made this sketch in 15 by 70 binoculars in the middle of the day. So even though the sky was quite hazy at the time, I was quite struck when I blocked the sun with the roof of the house. I sat back and then scanned around with binoculars, and all of a sudden the comet just popped out into view. And it was quite a fascinating sight, I must say, to see this comet in the middle of the day, tail and all. So even though the comet had remained visible only from the northern hemisphere up until that point, or daylight for us people in the southern hemisphere, it started to pop up into the evening sky for us. And this was one of the first views we got not long after sunset, where you could see the comet through thin cloud. This is pretty similar to what we saw on binoculars, this view. You could see it quite easily with the naked eye as well, but this is probably a view more similar to what you would have seen with the small binoculars. But the best we're saving for later. So on the 18th of January, 2 days later, it had moved out further into a dark sky. And this was very similar to the binocular view of the comet. You know, outstandingly bright nucleus, and this inner tail was so beautifully bright. So at the time I wrote a post about this, and this is my description I wrote at the time. Observed the comet from a fairly dark location at night, and it was a magnificent object from 60 kilometres southwest of Brisbane, Australia. Distant cloud meant that I couldn't follow the comet right to the horizon, but what a sight. The coma and curved 6 degrees of tail were very conspicuous to the naked eye by the time the coma had reached the top of the cloud deck. In binoculars, the central condensation was intensely bright, and the first 2 degrees of tail were very bright against the twilight. And I say that this image looks very similar to what I could see in binoculars. The coma was clearly not as bright as Venus, but comparison with it and Capella and adjusting for extinction, I derived a magnitude of -2.5. However, as the comet began to set, thinking that the display was over, as the sky got darker, we could see the tail, this fantastic display of almost like a auroral display of tail protruding up from the west horizon. If you look up here, you can see the constellation of Grus, which gives you an idea of scale. But this was probably around about 10 degrees or so. It really did look like an auroral display. And people often ask, can you see the structure with the naked eye? And the answer to that is yes, you could. The best view of this comet came, for me anyway, on the 20th, which was another 2 days later, when the comet had moved far enough out away from the sun and into a dark sky that we got a full view of the comet. And this view here was just a panoramic shot taken over the a lake near Warwick in Queensland. And you could, if you look carefully down here, you can see the crescent moon, and you can see Venus over here, and you can see the comet curving up around here. After this photo was taken, when it got darker, this was the view we got. It was absolutely magnificent sight. This was actually quite similar to what we could see with the naked eye. So after Comet McNaught, which is my category for daylight comet, I come to sun-grazing comets. And probably pretty fitting because this is one of the comets I found in 2011. And this is one of my favorite views, showing the comet piercing the sun's corona as seen in UV light from the SDO observatory run by NASA. I'd always wanted to see a Kreutz sun-grazing comet, and this is my artist impression of what a major Kreutz comet looks like with the naked eye, just based off descriptions I've got from some of the brighter ones that have been seen in history. So Kreutz comets are unique in that Kreutz sun-grazing comets are unique in that they're with only one exception, they're the only comets that approach the sun within 0.01 AU. So that's 100th of an astronomical unit from the sun. So they literally plow through the sun's corona. And in some cases, they actually have hit the sun. And I'd always wanted to see one. And back in 1999, even though I couldn't see this with my own eyes, actually found, if you have a look down here, a small fragment of a Kreutz comet. This is a composite image, so there was about 7 or 8 images combined in one. You can see the comet as dots moving in towards the sun. And this image was made from images obtained from the Soho Solar and Heliospheric Observatory, which observes the sun routinely and publishes their images online. And I was actually able to find this comet on their archive images. This was back in 1999. And that actually started a trend because I believe now the people have found about 3,000 of these fragments in Soho images. People just online, just looking at the images. I hadn't given up entirely hope of seeing one with my own eyes, but I'd never in my wildest dreams imagined I would actually discover one from my own backyard. But that actually did happen on November 27th, 2011, when I found the Comet 2011 W3, which turned out to be a Kreutz sun-grazing comet. And we didn't initially think it would survive the comet, the approach to the sun. In fact, I was a doubter myself. But when we watched it approach the sun, and here it comes, you could see on the approach, if I can freeze it, let me just start that again. You can see it approaching. And then if you look out here, you can see it reappearing here. So this was quite a shock to us to see this here and see it actually survive. So I'll run through. The next slide shows in UV light, comet going in. And then comet going out. And a couple of days later, we started getting views in the morning sky here, which took everyone by surprise, and me included. I've included this image here because you can see the Milky Way up on the right-hand corner, and this is one of the brighter parts of the Milky Way, so you can get a comparison between the tail brightness and the Milky Way, and you can see how bright the tail was. Even though the nucleus at that point had actually basically dissipated, the tail remained for quite some time. Unfortunately, I didn't get a good view at this time, but my best view came 2 days later on Christmas Eve. I got this beautiful view. In fact, we watched the comet's tail rise for about an hour and a half beforehand. There's somebody in my party that went out to look for the comet, had never seen the comet before, and we were standing out in a field out in central Queensland in perfectly dark skies, and he asked me, what should I expect? And this was about 2:30 a.m. in the morning, so about an hour before the comet was meant to rise. And I said, well, if you have a look over there, that shaft of light poking up from behind the eastern horizon, well, that's a comet. And I think his jaw hit the ground. I don't think he was expecting to be able to see the comet half hidden by the horizon with the end of the tail poking up into the sky. So a couple of nights later, I took this CCD image, and the reason I show this picture here is you can see how the actual head of the comet is disintegrated. It's almost featureless. So normally we'd expect to see like a bright starlight point in the center, but the physical nucleus has been stripped away, leaving it just a trail of debris of this image. So that actually concludes my top 10. So I don't know if people have any questions they would like to ask me, then I'll open.
Joe's been waiting for this moment. We've got a very important question for you, which is what's going into your brownies? There's fine chocolate and cocoa butter.
I don't know if Dave knows he's still muted. Dave?
Hi. Okay. So if anyone has any questions, David, do you want to, is this the normal format for you guys to have a question and answer?
Yeah, Dave's talking, but I don't know if he knows his mic's muted.
Ah.
I've unmuted everybody, but not myself. There you go. That's probably a good thing anyway. Well, brilliant, Terry. That's been a good rundown of some really, really nice comets, some of which I've been able to experience myself as well. Especially Comet Holmes, you had a fantastic view of that one some years ago up in Perseus as it expanded. So any other questions from anybody else?
Over to you then. Come on then, let's go. Come on, let's sing to some shearwaters.
No? Okay, well, I'm going to ask one then. How likely is it for amateurs like yourself to find comets now with all these surveys that are going on these days? Because it's obviously becoming much more difficult.
It's definitely quite possible, and people are still doing it today. You still have visual comet hunters. Don Mackholtz discovered a comet recently. I think it's recently as 2019, but it can be done, and not saying it's easy. I think the amateurs that have the best chance are probably amateurs with well set up imaging platforms. One very successful amateur astronomer Gennady Borisov actually has I believe it's a 16-inch f1.4 astrograph that he designed and built himself.
Wow.
Maybe be larger, and he's found quite a few.
And he discovered the interloper, didn't he?
Yes, that one nearly made my list too as a stellar interloper, but I could only have 10, so I had to compromise. But yeah, the answer to the question is amateurs still do. And it's getting harder and harder. It'll actually become very hard in the southern hemisphere shortly because we have the Large Synoptic Sky Survey starting up soon, which is an 8-meter aperture telescope that'll be scanning the sky, whole sky nightly, not nightly, over a couple of days. So very wide angle field of view with 8 meters of aperture. So they're going to probably clean up in the southern hemisphere, and also Atlas, the Atlas surveyor, are also starting up operations in the southern hemisphere. So it's actually probably going to be as hard in the southern hemisphere to find comets.
Right.
But yeah, people are still finding them, but it's getting harder.
Yeah. Lee has asked, what sort of binoculars are you using or recommend?
Always recommend a lightweight pair of binoculars. So 10 by 42s or 10 by 50s are always great. And then I have a larger set of binoculars, 10 by or 15 by 70s or 15 by 80s.
It was more specifically what quality.
Sorry, I just missed that.
It was more specifically what quality.
Okay.
To be honest, I've never owned good quality binoculars. I've always owned cheap binoculars. Limited funds to spend. I'd probably spend more on a camera, and I don't do as much visual searching. I don't do much visual astronomy with binoculars anyway these days.
Could you mute your mic if you're not saying anything?
Yeah, I'm just trying to.
Okay.
Is that better?
Yeah, that's better. Okay, Sandy's asked your thoughts on Comet Atlas. I know you mentioned it a little while ago.
Very interesting comet. If we're talking Y4, because there's a couple of Comet Atlases out there, there's actually 2 that are visible visually with amateurs at the moment. But I think I'm going to assume you're talking about 2019 Y4. Fascinating comet. We need to keep watching it. It may have some surprises still in store for us. I know there have been predictions which I've just should be totally ignored. Unfortunately, a couple of the well-known astronomy sites have published predictions saying it could get to magnitude -5. I just ignore them. It's just totally unrealistic, very unlikely prospect. But I think more interestingly is to see what will happen with the nucleus as it gets closer to the sun, given that it's already starting to fragment. It really is developing day to day. We've seen what looked like the comet was going to disappear and fade away. Comet has stopped fading. In fact, there's been some observations suggesting it's starting to brighten again, and the main nucleus is starting to brighten. So, keep watching. I wouldn't be expecting anything with the naked eye, anything impressive with the naked eye or even visible with the naked eye, but definitely it's worth keeping your eye on. Really interesting comet, that one.
Tom's asked about the 2 tails. Can you just explain about the 2 tails, especially with Hale-Bopp?
Okay,
Quite aware.
There's 2 primary tails. There's the ion tail, which is essentially fluorescing gas which gets driven away by solar radiation and interacts with the solar wind. So you get interesting magnetic effects that cause filaments and different structures within the iron tail. Iron tail tends to be a very bluish color, distinctly blue. Although with the eye visually, you don't see that color, but certainly in color photographs, you see that. They tend to be straight, although with the interaction with the solar wind, you can get some contortions in the tail away from straight. They are quite fascinating to watch photographically. Then the other type of tail is the dust tail, which is basically formed from dust that is lifted off the comet's nucleus and gets slowly pushed away by solar radiation pressure, and tends to have a curved shape because the particles are moving slower. So these are the dust tails in a well-formed comet tend to be brighter than an iron tail, and the color is yellowish, which is more visible with the eye than the iron tail. So they're the two different types of tail. There's the dust and the gas tails, the main types.
Okay, John's also asked a question about one of your images of C2011 W3. Was that a single exposure or stacked photo?
That was just from memory. Actually, I did 10 second exposures, and because I had a small format camera, that was actually 2 sets of stacked images. So it was actually a mosaic image. So it was only 100 seconds total exposure.
Okay, and Tom's also asked why comets look green.
The green, I believe, comes from carbon. So decomposition of things like methane or ices on the comet leads to diatomic carbon. So one of the products is 2 carbon atoms joined together, diatomic carbon, that has a charge, and when that fluoresces, it fluoresces strongly in a couple of wavelengths that are in the green part of the spectrum. So hence you get a very intense green color.
Okay, any more questions? No more coming through on the chat. So, no, so if there's no other questions, thank you very much for getting up very early for us this morning, Terry, and giving us your talk and a good overview of some wonderful comets.
Thanks for having me, and I apologise for running over too. I realised I looked at the clock and we're...
Not a problem. Excellent. Okay, well, I hope everybody's enjoyed Terry's presentation tonight, and get out there and have a look at Comet Atlas, because it could still be quite interesting. It may not have breathed its last yet.
I recommend it, and I've already booked out a lot of telescope time in May in New Mexico, so I'm actually anticipating it'll be quite interesting come May.
Great stuff. Okay, right. Okay, so everybody, I'll sign off now. So thanks so much, Terry.
Thanks, Terry.
Thank you.
Thanks,
Bye
Terry.
bye.
And speak to everybody on Thursday. Okay, thanks much.
Bye,
Bye.
guys.
Bye. Keep well.
Thank you. Bye.
Smith got